Good day, students and viewers. You are welcome to the studios of Mathsx. In our previous video, we converted numbers in base 10 to other bases, and we used a method of continuous division. In that video, I explained to you that to be able to conduct such operations, you, the student, must be very acquainted with your times table. And that way you would know how to do your divisions and of course write down your remainders. In that video, I showed you how simple that operation is, and I trust that you were very educated on what to do when confronted with such problems. In today's class, my dear students and viewers, we will be learning how to convert numbers in other bases to base 10. But just before we start our class, as it is our culture in our studios, we want to honor or rather recognize our subscribers for the week. Thank you so much for giving us good value. God bless you. So, my dear students and viewers, for the first part of our class today, we will be converting numbers in other bases to base 10. My dear students and viewers, our first example in converting numbers in other bases to base 10, the example says convert the following numbers to base 10. My dear students and viewers, for our first exercise, which is 3, 2, 1, which we're going to convert from base 4 to base 10, we have 3, 2, 1 at base 4 to be converted to base 10. We're going to do something we learned in our primary school to do this conversion. It's called place values of numbers. We learned that in primary school. And in that light, we're going to write a 0, a 1, and a 2 as superscripts on top of each of the numbers. These numbers will find their use very soon. I will explain. Now, going for our place values of numbers, in our indices, if you have any number to power 0, what is that? For instance, if we have, this is a rough here now, my dear students and viewers, if I have a 4 to power 0, that is a 1 by laws of indices. If I have a 10 to power 0, that is a 1. Any number to power 0 is a 1. So the first unit you are seeing here, the first digit you are seeing here with that 0 on top, it speaks of a unit of that particular base. Whether it is base 10 or base 4, this is the unit of it. If I have also a 4 to power 1, let's use a 10. That will make it lighter. How about a 10 to power 1? 10 to power 10 is a what? A 10. This speaks of a tens of any particular base that is being used. So if I have a 10 to power 1, this is a tens unit. Like I said, we'll be using our place value. So this is a units, a tens. I'm sure you can guess that this is 100. Yes, because this is 4 to power 1, which is a 4 itself. Of course, 10 to power 1 is a 10. This is in base 10. So 4 to power 1 is a 4. This is in base 4. However, how about to power 2? Let's start with a 10 so we can relate. So 10 to power 2, this is 100. So this is the hundredths units. And for the 4, so this is a 4 to power 2. So this is its own hundreds in base 4. So that's why I'm using base 10 to explain, because I know that in a base 10, we will relate to that one better and easily. So this is the units of this particular base, the tens of this particular base, and of course the hundreds. There can be 1,000, thousands of a particular base. Just like we have it in base 10, which we'll be using. That's why I said that we're going to use something called place values of numbers that we used in our primary school in solving this. So in its use, our next step will be the expansion process, which is what we are going to use to solve, because typically to convert numbers from base 10, from other bases rather, to base 10, it's a process called an expansion process. We're going to expand these numbers conscious of their place values. So here we go, my dear students and viewers. This was just for the explanation. I'll take it off to avert confusion. So we have here a 3 times 4, there's a 2 here, to power 2. This is its hundredths digit, plus a 2 times 4 to power 1. This is its tens digit, plus a 1 times 4 to power 0. This is its units digit. So, and this is the expansion process. I've expanded the number. So here we go. This is 3 times 16, because 4 to power 2 is 16, plus 4 to power 1 is 4. So we have 2 times 4, plus 1 times 1, because 4 to power 0 is 1. We have a 1 times 1, and then we close. 3 times 16, that is 48, I'm sure. Yes, it's 48. Yes, it's 48, plus 8, plus 1. 8 is 2 times 4 is 8. 1 times 1 is 1. So we have here, this is 9. 9. We have 57 at base 10. So therefore 321 base 4 is 57 base 10. Let's try the next one, the B part, which is 10222 base 3. This is a 5-digit number. This was a 3-digit number. We had 2 up here. So for our 5-digit number, we're going to have a 4. This will be a 0, a 1, a 2, a 3, a 4. Meaning that this number has 1,000 in base 3 and its own 10,000. Yes, in that particular base. So the expansion will continue. So we have a 1 times 3 to power 4 plus a 0. In the future, when you have 0, you will tend to ignore that number, because 0 times a particular number is still 0. But for learning, let's use it. So we have a 0 times 3 to power 3 plus a 2 times 3 to power 2 plus a 2 times 3 to power 1 plus a 2 times 3 to power 0. 1 times 81, because 3 to power 4 is 81, plus 0 times 27, 3 to power 3 is 27, plus 2 times 9, 3 to power 2 is 9, plus 2 times 3, 3 to power 1 is 3, lastly, plus 2 times 1, 3 to power 0 is 1. So we have that 81 plus 0, that is 1 times 8, 81. 1 times 81 is 81. 0 times 27 is 0, plus 2 times 9, that is 18, plus 6, 2 times 3, then of course plus 2, because 2 times 1. This is 20, 26. 26 plus 81 is 107. So what we have here is 107 in base 10. So in other words, therefore, 10222 base 3 is equal to 107 base 10. This is the much we can take in today's class, my dear students and viewers. I trust you've been thoroughly enlightened. In our next class, we will be talking about conversion of fractions in other bases to base 10. Until we meet again, like, share, and subscribe as usual.